Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready. Let's get started. Guys, welcome to the second video on the differentiation series. Remember that on our previous video, we looked at basic rules that we said we must introduce for us to be able to lay a good foundation to be able to solve differential equations. So in this part of the video, we are looking at differentiating trigonometric functions. So before we go any further, there are some rules that we need to get at the back of our minds so that we can be able to solve any problem that will come our way as far as trigonometric functions are concerned. So we've got functions and we've got their derivatives, right? So whenever you're given a function, like here, you can see that I've got functions, then the derivatives right here. So for the function cos of x, like this, the derivative of that is minus sine of x, right? Then the function sine of x, the derivative of that is cos x. The function tan of x, the derivative is sec squared x. The function sec x, the derivative is sec x tan x. Then the function cosec x, the derivative of that is minus cos x cot x. And the function cot x, the derivative of that is minus cosec squared x. So these are 6 basic trigonometric functions and their derivatives that we need to keep at the back of our mind for us to be able to solve differential equations involving trigonometric functions. Right. So on our first example here, the first question will be saying differentiate the function y equal to sine of 2x, like this one. So how do we go about differentiating such a function for us to be able to arrive at the answer minus 2 cos 2x? Right. So the first thing that we need to do, remember we say that the derivative of sine x is cos x, right? So we've got a function y equal to sine of 2x, right? So dy over dx, which means the derivative of this, of sine 2x, right? So how do we simplify this one? So we say that the derivative of sine x equal to cos x. So it means that the derivative of sine 2x is equal to cos 2x, right? So after doing this, we don't stop here. So we have only differentiated for sine 2x as a whole function. But remember, I've got a constant, right? A value that we are multiplying x by, which is 2, right? And we are going to differentiate 2x, right? So if we differentiate 2x, you're going to get a number 2, which is equal to 2 cos of 2x. So in the first problem that we had, right, in the first example that we had, it was saying y equal to sine of x. So I want you to note, guys, that the number that is before x here is 1. And the number that is before x here is 2. Right. So what does this mean? This then means that for the first example that we have on our derivatives list, right, it was saying dy over dx of this equation here, right, will give us cos of x. And because the derivative of x here, right, is 1, if you differentiate x the power of 1, right, you're going to just get 1. Are we clear about that? That is why here, if you multiply by 1, you're just going to get cos of x, right? So that is why here, now, where we say it's sine of 2x, the derivative of x, this one here, is not 1, but it's equal to 2. So if you then differentiate 2x, you're going to get 2. That is why we had to multiply by 2 right here. And our final answer will be 2 cos 2x, like this. I hope this is clear, guys. Make sure that you understand this. And the second example that we have is saying y equal to tan of 1/3 x, which is this one. So remember, we say the derivative of tan is sec squared x. So tan x, the derivative of it is sec squared x. If you've forgotten, refer to the first part that we said we are going to have the function and the derivative. So the derivative of tan x is sec squared x. Now, when differentiating tan 1/3 of x, we just apply the same rule that we applied on our previous example. So we're going to get the derivative of tan, which is sec squared. But remember, this is no longer tan x, but it's tan 1 over 3x. So we're going to write sec squared 1 over 3x. Then the derivative of 1 over 3x is 1 over 3, which is here. So our final answer then will be 1 over 3 sec squared 1 over 3x. I'm hoping this is clear to you guys. I don't want you to get confused. So the next example that we have is y equal to cos in bracket 3x minus pi, right? Which is this one here. So it's the same principle that we're going to apply. So the derivative of cos is minus sine. So cos x, the derivative of cos of x, remember, is minus sine x, right? But now we have cos bracket 3x minus pi here. That's what we now have instead of x. So the derivative still remains the same, right? So the derivative is minus sine 3x minus pi, right? But now we also have to differentiate, right, what is in the bracket. So dy over dx of 3x minus pi, right? If you differentiate this one, you're going to get 3. So that is why our final answer will be minus 3 sine of bracket 3x minus pi close bracket. I'm hoping this is clear to you. Then moving on now to our fourth example, which is our final example, is saying y equal to cot 1 minus 3x in brackets. So it's the same principle. The derivative of cot is cosec squared x. So cot x, the derivative of it is cosec squared x. So if you apply the same principle that we applied on the previous example number 3, we are going to arrive at this answer here. So we're going to end up with positive 3 right here because we've got a negative here and a negative here. So if you multiply the 2, we're going to get a positive sign. So now we might also have trigonometric functions, right? Whereby the power of the trig function is not equal to 1. So remember, in all these previous examples, the power of the trig function was equal to 1, right? So how do we go about solving such a trigonometric function in terms of differentiating it? So remember, in the previous examples, we were having expressions like y equal to cos of x. But this time around, we are having y equal to cos of 3x, right? So it means that the power of this trig function here is 1, right here. But the power here is no longer 1, but is 3. So that's what I mean by when we are given trigonometric functions who have got power that is not 1, right? That is 2 or more. So how do we go about solving such trigonometric functions? It's the same principles that we were applying. Remember that in the first video on differential equations, we had basic principles on solving, you know, expressions whereby we have got a power that is not 1. For example, when asked to say what is differentiate y equal to x squared. Remember, we're saying dy over dx would bring down our 2x, then you say 2 minus 1, which is 2 the power of x. So it's the same principle now, because the power here of a trig function is no longer equal to 1. So how do we go about this? We're now combining what we learned in this video with what we learned in the previous video. So remember that the derivative of cos, right, is equal to sine. Cos x, the derivative is equal to minus sine x. So the first step we need to apply is that we have got an expression that says y equal to cos of 3x, right? So dy over dx, we're going to bring down the power 3, cos of 3 minus 1, you're going to get 2 of x. Then we are going to differentiate now. What is the derivative of cos x, right? The derivative of cos x is minus sine of x. So finally, our answer will be minus 3 cos squared x sine of x. So that's what we have here. I hope this is clear. Make sure that you understand the basic principles so that we can be able to solve the complex ones. Thank you.